Team, welcome back everyone. Welcome back to day 8 for our Java plus Python training. We're trying to look at both the programming, the popular ones, languages. In parallel, we're going through the execution of them. Previous session team, we've covered a lot of things. We've done, at least in the day 7, file handling, exception handling, and how we use these exceptions and handle different types of exceptions, both in Java and Python. And I gave some coding challenges to you all. I'm not sure how much it is done, but I would love to come to that a little later. Today I have to cover a few important topics on OOPS team. And this will be very interesting, and it is also something that requires your full attention. So everyone with me so far? So I'm going to talk about what this concept is and how it has evolved for us. Okay, so this as first hand jobs. And so we're talking about any objects in real life. Now, what happens is one of the most important aspect of OOPS is that why not consider real life kind object behavior for programs too. End of the day, the whole concept is what we are interacting with are different kind of objects in our real life, or even data as an objects and so on. So how can we look at that as a process put together? So the basic concept is very simple, team. Let us talk about a few objects right now. Okay, let us say I have a box. Now this box basically has a height, a width, and a length. That's an L. Now, what happens when you define a box, when we think of a box team, is there are two things that will happen. One are the properties of a box. The second are the methods or action that can be performed on a box. So what are the methods that you can perform on a box? You can open a box, you can close a box, you can pack, unpack, and so on. So different features that you could do on a box. Now, any object that you look at will have this structure. Now, what are properties? We spoke about methods being different actions that we perform. And what about properties? Properties are primarily something that we use to describe. So I could basically say the description of it, or in some cases, the identification of it. Okay. So how do we describe an object? How do we identify these objects? So we're just talking about objects in general right now. So now for the same instance, if I take a human, for a box, we saw that the properties are more like height, width, and length, and maybe a color of a box, the weight of a box is the other descriptions that we could give. For a human, when it comes to a human, we are probably looking at something different, how we describe a human and how a human acts. What are the actions or methods a human performs? So human basically can communicate, can think, can walk, talk, all of these things that a human can do. Now think very closely of the properties of a human. What could be something that we could describe a human? We could talk about a first name. I could give a last name. Maybe even, but first name, last name sometimes could not be common. So you have email IDs or phone numbers or social security numbers or PAN card numbers, or maybe your DNA itself as it gets final and finer, your fingerprints. All of this, some are used to describe you, some not actually description. This is just to identify. Now, when we talk about a description of a human, we talk about the height, the weight, the eye color, the hair color, the ethnicity, the age, the date of birth. So there are so many other things that describe a human. So primarily, objects can have two things: properties to describe or identify. So describe is like a red box, or the how do I say, sports car, okay, or the tall guy, used to describe. But the same thing for a box, I don't know, maybe a barcode is essential. For a sports car, maybe a vehicle identification number, license plate number is essential to uniquely identify it. For a tall guy, maybe an email or DNA, something used to identify. So there are two different things, Tim. There is a description and there is a identification. Okay, and these are the properties for any given object. All objects typically carry some properties. The more the complex the object, the more properties that get added for its creation. Okay. Now, the second thing that the objects have are called methods. Methods are actions that we can perform on these objects. Okay. And we also call this as actions, functions, etc. But primarily they're meaning the same thing. So the whole concept revolves around taking any object and saying that I want to put it as how I can describe it, how I can identify it, and so on. Now think of it. I have a box. I have a human. I have a smartphone. Okay. Each of them have their own properties and methods, own properties, methods, own properties, methods. Now, we're talking about any box, any human, any smartphone. And that object gets very specific to one object or one specific human, okay, or one specific sports person. That is basically you've created an object. Okay. But the structure, that how a box should look, properties and the methods, how a human should look with the properties and method, and how a smartphone should look. So this smartphone, this image is sorry. This format or a framework or a structure that is provided is basically our class. So class is like a blueprint. So I will say, let us say there's a team, a group of 50 students in a classroom. I will divide and say maybe everyone's name that is starting with A stand here, and everyone else with S stand there, and everyone else in third category stand in one group. So I'm dividing each of them based on certain things. So every object still belongs to that class. So every class basically says that this class is, for example, a box. When there is my box with a specific color, height, weight, and length, then it becomes an object. So primarily, it's a very simple concept. Class is a blueprint for an object. contains the standard of list of properties and list of methods. You can create an object from that class. At that time, you have specific information going into it. I'll talk about what it does. Now, example, let's say class is human, properties. Actually, which one should I take? I'm just thinking. Let's stick with the car itself. We can do a few easy ones with it. What properties am I thinking? I'm looking at a make of it, the model, and the year. And what are the methods that the car can do? It can drive, it can park, it can refuel it. Okay. And here I'll also say fuel capacity. How much? Fourth variability or fourth parameter. Am I being clear, everyone? I'm just talking English so far. Now we've got to put that into our programming. Can I get a nod if everyone's with me? Okay, I'm going with it. But that's my class, that's my properties for it, and these are the methods. Now, the object is myCar 1. It is basically, let us say it's a Ford, and I'll say F-150 2010 fuel capacity is full. That's the details of my car as of now. Okay. Now, using the same model, I'll create your car, and here I'll say it's a Beamer, let's say 2019 and 5, and it is half that. This is our given idea. So we've created two objects. Okay, now here is my layout, the blueprint. So all this that I gave is basically saying how it must look or what it will contain. Okay. This giving the direction. Okay, it's called, the name is the car, these are the properties for it, and this is what you can do. So the methods are common for all the cars, what you can do with them. But the properties are the one that are different for each. My car, your car, the neighbor's car. Now, these are the objects. And how many objects did I create here? 3 objects created using the class car. Okay. Now, let us try and do the same thing without wasting any time on our Python. It's trying to teach my son programming. py16 hyphen classes. So primarily, let us say I create a very simple to start with as basics of classes, and then we will expand on it. If I say class, my class one, you remember how we used def to define a function? That is how we are doing it here. Now let us create two variables called x. I'll put some data into it called 10 and y as 20. Now this class, this is the name of the class. These are the class properties slash attributes. Sometimes we also call them as attributes team. And that's it. That's my class. Now what I'll do is I'll go to my main function and I'll say print hello start, and I'll end it with print hello end. And let's just run this code as is. I'm not going to change anything. Hello start, hello end. Okay, none of these blank statements ever correct. That's what. Now this is the class definition here. It is my main Python. In here, what I will do is create an object of my class one class. Okay. So how I do it is very simple. I'll say O1 object one equals my class one, open end brackets. It looks like a method called team, but primarily at this point, what will happen is there is an object called O1 create. Nothing would come because we're not printing anything. But if I print O1 dot, I would see the two arguments or properties that we create. So that's my X, and print O1 dot Y. Now here is one class, or rather. Now if I create the second one, O2, it will still link to the same class team because it's using the same template. This is my blueprint for the class, that format. And in this case, I'll print O2.x and O2.y. Now look at the values, it's the same values. But what happens if I say O2.x equals 1000 and O2.y equals 2000? And then you see, so now O1 will continue, object 1 will continue with its own values forever. Object 2 can do what it wants with its own value. Two different creations of the same class. And the two different object creations of the same class. So how did we do it? Created a simple class, just properties. We did not do any methods in to show how this works. So at any point, even here, if I say again O1.x, it will have the values whatever it has. So object O1, my class is there. From that, I create an object O1 and I created an object O2. These are two different objects now. They'll have their own life. They're independent to each other. Okay. Now let's create another one. Okay. So this time, let's take a more practical example that we can understand. Something exactly like this. So I have a car and we have these properties and these are the methods. So let's design this class first. Template / blueprint. How does the class look? So that way what happens, one of the good things is every object in the class will behave in a similar fashion, okay, and are bound to those specific properties and methods. They cannot do anything. So for example, you can open a box, but you cannot really open a human till they're alive. Like, yeah, you can do surgeries. That's not what we're trying to do there. Now, let's do it for a car. So very quickly, class car colon. I have a car make. I don't have anything into it, so I'll just keep it as blank. Model, year, fuel equals 10. So 10 is full, 0 is empty. Okay. So now let's do something. These are the properties for a car. Let us create methods within the class. See, this method is getting created within that class. It is only accessible for the object that we create from that class. Let's say drive. Okay. I'll talk about what is self a little later, and then I will say, what do I say? Distance. I'll send that variable as an import. And here what I will say is print driving for comma distance. That is one. Next, what I'll do is see fuel equals to see fuel minus distance, whatever distance we're doing. So primarily, if you're driving, you're losing fuel. So let us say I have one more like this. Basically says park. In this, I will not pass any variables to it. So I'll just say parking. And there is no change in what I'm doing here. F is for function T. Remember that, please. This I may need to do self.see fuel and self.see fuel. Yeah, that's correct. I should not have introduced this, but that's fine. Now, these are the two things that I have. And let us say I create a car team. What is the name of the car? A car, right? This is C1 equals to a car. Now, by default, C1 dot fuel, C fuel, if I print this, it would definitely be 10 all the way. Oops. Okay, so that is one car that we create. Now, but let's give the make and model. So I have a make, let's say, C1.c model equals C1.c year equals 1999. Right, and we have the fuel. Now what I could do is if I say C1 dot park, it would go and park that car. Parking car, comma, I'll say here self dot the make. Now let's observe what happens here, team, as a regular run and then as a more detailed execution. So c1.park is there and print c1 fuel is there. c1.drive for 5 half the time. Now then I will again print c1.c fuel. So now let us think through. Can someone tell me what are we expecting here when we hit execution? What do we want to see? The fuel left. And what will it print? So let us say we drove it for 3 instead of 5. If we give 3, then how much is left? 7. That is what we are expecting. Exactly. So we're just talking this about as distance, but I'll call this as fuel distance, a new name. Okay. If I change it there, make sure you change it here to team. Okay, it stays there. Now let's run and hope we get 10 and then a 7 in the bottom. There we go. 10 parking car, Porsche driving for 3 fuels, I can say. Parts of the tank. And then C1 park again. I'm done. Do you see how it's behaved to my car? Now using that same format, I can create an exact replica of it. Maybe some things are different. Of course, I'll say this is C2 now. I think I should be able to do a controls F here. C1 and trying to find and replace option, but it's fine. C2 C2.C. Now we change the whole thing here. So I say this is a Beamer and this is an M5 and let's say it's 2019. We try for 6 and that's it. Now there are 2 different cars that we've created from the same object pattern or blueprint. That's the class. The class gives me a definition of what should be done, where it should be done, and so on. Now, let me explain the concept of this as a line by line for you all. I've created a class. The definition starts here and it ends where? Here, line 16, from line 5 to line 16. In that, there are few variables. So whenever I create any object using a car, it will use those or it will have those variables that you can fill information. Now, what we are doing is we have 2 methods in here. These methods basically do certain actions on that object. Okay? Which object should it do is defined by this cell. Okay? In the sense that when I say C1 dot drive park here, okay, it comes to park, and the self is basically referring to C1 at this point. So this C1 that you see, this C1 that you're seeing goes directly in here into self. So in the sense, it knows that on the current object we need to use. And in Java, we use this and all that, but let's come to that later. But this self is basically saying on the current object that we use. Now, there are two methods, team. The first is drive. It has two arguments. The first is basically talking which object. So even if you don't pass any argument, by default, it will have one that is called the self. Self is almost like zero arguments. So when I'm calling a method like par, I don't pass anything to it. Self is basically a pointer to that object. So when I say self.cmain, it is giving me whatever is there in c1.cmain. That is Porsche. When I'm doing the same call from c2.par, it is giving me BMW out here, because self then is c2. So when it is getting called that method, which object is self? Now what is drive doing? I'm sending two parameters, actually one only. Self is that current object. How much distance I want to drive? I'm saying fuel distance. So I'll drive for 1/3 tank or 7th of the tank or 8th of the tanks. That is what we're saying. And here I'm taking the old fuel that the car came with, and we are putting this. So I could add now a new method, for example, and I'll say refuel. So self comma fuel amount that we want to put. So what will I do? Self dot c fuel equals self dot c fuel plus fuel. Okay. Now in this case, maximum capacity is 10, let us say. All right. So I will then put an if statement here. If self dot c fuel is greater than 10, okay, in this case, I will say self dot, change it back to only 10. All right. So it will not overfill, not the greatest of a logic team, but just as a concept for us to understand this. I think that is exactly what I've been explaining what self is so far. Who can explain what self is once again? Let us say I create, listen to me very carefully. When I create a car called C3 is a car, okay, I say C3 dot R and say C3 dot refuel to 10 more. So what I will do here, print overfilled stopped at 10. And here I can also say self dot C print. Let's see this. So I have C3, I'm just saying park and refuel. Now in this case, when I'm C3 is my name of the object, everyone focus. When I call C3.park, where will it go from line 46? Can you tell me please, anyone? From line 46, where will it go? It will come to line 15. It will try and execute that. it will then say that the self is nothing but the object name. What is the name of that object? C3. So when I say C3 here is self, so it's nothing but C3.cmake. And I'm calling C1.spark. The self will be what right now? Tell me everyone. That name of the object, which is C1. And it will give that make of. The same goes for everything. Okay. Only the parameters that we are sending as inputs, like fuel here or fuel distance here, I don't use self. There is no self for it. There is no argument here. For the others, I'm using self. You'll get this as you keep practicing. Just 3 objects now that you've created. So I'm saying refuel beyond 10 for C3. Let us see what happens now. And we will try and execute this also in a debug mode. Okay, parking car overfill stopped at 2 10. Then here I can say, now it can be very interactive. Refueling what's that? Comma self dot c make what car we do. All right, now let us say I drive for 8 and I fill 1. Then how many will be there? C3 dot fuel again. Sorry, C fuel. It will tell me the value. All the properties are nothing but C3 dot the name, no brackets team. Methods are the only ones which have brackets. Now let us do this. Let me put a breakpoint on line 46. And let us do a debug run here. I don't know if we did a debug run earlier in Python. Functions inside class will always start with self as one of the arguments. Okay. I think now we have hit that value here, team. So see, do you look at these variables out here? It says, oh, they created C1. It's got fuel 7, Porsche 911 1999. Then there's C2, 4 BMW M5 2019. Now, when I create this, what will happen to you? Actually, one of the challenges, if you notice, I did not put the make, model, or year. I did not do that. So it is empty. But can someone tell me the formula? So we already have 10 to begin with. Then we drove 8. And we're refueling 1. So how much will be there in the tank? 3. Correct. So we drove 8, 2 was left, we add 1. So we're expecting 3. That is 1. Someone said semicolon missing after something. Oh, I added a semicolon. It ignored it, I guess. Okay. Now at this point, team, let's go step by step. Here, where will it be? Step into. Step into. Now it has created that C3 as a car. Did you see this? And the only thing it gave was default fuel of 10. No make, no model, no year. Why? I did not initialize it like I initialized the other objects. Okay. Now what happens here? Next step, let's see. Step into. It's gone to park. Now it's come to the line 16. At this point, it knows self is pointing to what? In that current self, do you see the details? 10 and everything. This is my self object currently once I'm inside that method. And I hit on step into, and it has printed that for us, hopefully. Let's finish this. I'm trying to look at the console. There you go. So yeah, it's printed that. Back to our debugger. And I'm clicking into this icon again. So now look at drive 8. What does drive 8 do? So it will go into the drive. Fuel distance is 8. Do you see that value under it? Self is this object which has all these details of pens, nothing, nothing, nothing. Okay. And now it will come into that next line where it will take that old value and subtract it from it. And then we're going into refuel. And at this time, it is looking at, so it's basically, what is it giving in console? Let's see. Driving for 8 parts of the tank. Okay, good. Now we are refueling. So it basically will tell me in console, refueling self.cmake is empty. So that's why it didn't give anything to us. Now fuel has value. Fuel has 2 in it because we already drove 8. So what will it do? If it is greater than 10, do all that. Otherwise, new fuel is 3. That's good. That's what we wanted. And we're asking how much is the fuel. Why didn't it print C3.fuel, C fuel? It should have printed, right? After new fuel. Oh, I didn't use print. How will it print? So that's done thing. So here I can print. This is my C3.C fuel. Here, everyone. So one class, few properties, 2-3 different types of methods into it, and we can create many number of objects as under it. Make sense, everyone? And do definitely repeat this video, and for sure, please practice. py18 hyphen classes. So I just want to let's look at the same one. Car. And there is a method called initialization. When creating the object. So let us say I give underscore init. Do you see this init self? In here, if I pass that CMake, C year, C fuel, for example, and in this case, I have to say self dot CMake, or it could be a different name here that we give. Make equals CM, and then this is year. I'll explain this code to you, team. CF fuel. And let's say I just have another method here. Get my fuel. Nothing as input. And this will return for me self dot fuel. See. Now see how easy it is in Python. In the same code, when we write in Java, you'll see the little challenge that we will go through, just the size and structure of it. Now for me, it's very simple. I say C1, a car, and earlier we used to just give like this in the previous code, if you observe. Now this time we have created something called as an initialization method. What this does is, when we are creating the car itself, I can send some details to it. 1, the 3 in fact. Fuel is 10. So instead of having to go each line and create it individually, I can create it like this easily. Yes, visible everyone? The difference is, when you're creating itself, you don't have to initialize separate. See here, for me to do that, I have to split it into 4 different lines. Instead of having it in 4 different lines for me, these 3 and line 26, I have it now in 1 line. That's the big difference. And now I have 3 different cars. So each of them will get created. And if I say C1 dot get my fuel, print, so I'll have print of this, and C2, C3. So now let's do a debug run again. So line 12, double click, click on, click just a single click to get the debug entity and run in debug mode. So let it hit the debug mode. We'll step into here. So it will go in, oh no, it's running the old code. There is P18. Okay, good. Now debug please. Okay, we hit the debug point. Where are we? So I am here now. See, it says C1 a car. It has gone to creating that key. In our case, it did not do that for us. It was basically did not have an initialization, and it will perform all of those steps there. We'll just step over, basically out of it, and then it's initializing the next object. So it is basically has now created these 3 objects in 3 single lines rather than a bigger structure. And later what will happen, you will notice that this data also can come from a different source like JSON or in Excel and so on, what you want to create. So at this point, I think we've reached there. So let's resume run program and look at console. I got all the outputs, what was aligned. So yeah, did you get the basic idea, team? All we discussed was primarily about how you create a class, and you can put some properties or methods. And then once you create the class, you can add values into it, you can change, you can use them. For each object, it will have its own instance. So primarily from one class, you have multiple objects coming in. So from a class of box or a human or a smartphone, you have multiple objects that keep coming. Clear, everyone? Any questions, please? let's try and spend a little bit more time on Java theme. So the same concept is kind of applying for us here. Just thinking, should I create a separate class and show you, or within that same class? Within the same class is confusing, but if I show you in a different class, okay. Let us get started, team, and we'll try and talk about this. In this case, what I will do, everyone, is I'm going to create a very similar class. I'll put it outside. I'll show you. So here, I'm going to say class, the same thing. And we're going to name this as myCar. I will not put a main method for it and just create this. So primarily what we've done is we've created the structure of myCar. So here I could put my initial variables and say in fuel equals 10, then string C make, C model, C year, the same approach. We're defining what it is, and I will have functions. Void. What was the name of the functions that we use here? Drive, park, refuel. So let's just do for now, I'll say simple drive. So driving my car plus. Let's just do a simple one for now, because Java will be a little complicated. I want to take an additional session on this. I also want to review your assembly. Drive is there, park is there, and I'll say refuel. Now what I'm going to do, team, this is all that I have. This is this one. So out here, since both of these are in the same package, team, I will basically say C1 myCar C1 equals to new myCar. So basically at this point, we have created an object using the myCar class in the same package. It is in the same exact package, so there's no restriction for this. So here when I say C1.fuel, I would have that value of how much fuel is there. And I could say C1.drive, that's my method, C1.park, that's my method, and C1.year. What else is there? So you could look at all the methods also here, team, refuel. And these are the different methods that we are executing right now. What does it say? There's no, oops. One second. No, it's okay. Let's say and try and execute classes run as Java applications. So 10, driving my car, parking my car, refueling my car. So you're basically creating the whole model of how the car should look, what should happen into it, and so on. Now into the same thing, team, you could add an initialization or what we call as constructor in Java that basically will have the same name. I'll say public. Actually, I don't need to use static, but that's fine. Static void my car. So when I give the function with the same name as my class name, that becomes your constructor. So in this case, I could take my variables and put them. I could say my C make is what, my C model is what, my C year is what. So if I send this as M string M, string see how much code we are writing, team. I would really want you to do the same. Write as much as possible. That will give you a good amount of confidence as well. Make this I don't need static, team. I'll explain static. It's a very simple thing later. So basically, I can use static. The thing is, if it is static, I don't need to use an object to call it. We'll talk about it in the next session. But let's finish the basic structure of this. Now, the constructor in Java goes with the same name, and you pass these details. So change to constructor. This method has a constructor name. Okay. I don't need void because it's not doing anything in this case also. Doesn't have to. And now when I use myCar to create, I have to send those three details. So I can say it is A, comma, 1, comma, whatever, 2000. So that becomes one car. And this way I could create any class, and that's my constructor object. Clear everyone with how oops as a basic is used and how we're able to build classes, put properties methods to it, and create objects from it. A few more things to do on it that we will learn. On Java and Python, a lot has to be done more in terms of understanding the different complexities with node,s a little bit more. But I hope this gives you a good head start, everyone, as to what we're doing, how we're doing everything. And now you could go here and say driving my car. Let's see, make. So, yes, see, make here also. And let's see. So a rerun would basically give me everything quickly. What car it's driving, parking, refueling, and that's good. That's okay. So that's Java. This is Python. Good, everyone. Any questions, please? No need to compile main class. So when we are executing, it is doing the compilation as well. So right click, and when I'm saying run this Java application or program, it is compiling, then it is executing first. If you're using too much command line interface, CLI commands, then yes, you'll have the other issue. Team, anyone wants to show their assignments today, or should we switch it to tomorrow then? In Python code, as many number of arguments can be added after self. That's correct. And even in Java, you can add any number of arguments. It's basically what your method requires in it. Okay. All right, great everyone. I hope this session helped you. The basic idea of how classes work. Practice on this, and then speak back with you. Thank you. Bye all.